today we're going to look at stoichiometric relationship between reactants in forming a product. The technique that we're going to use is based on gravimetry. Basically, this technique requires you to measure quantities in exact amount using weight. Weight is gravimetry. So therefore, in this procedure, you will be paying a lot of attention to ensure weight data is representative of the data that you're collecting as much as possible. Here, first of all, let me introduce you to the equipment that we're going to use. The very first equipment that we're going to use is a crucible and a lid that goes with the crucible. This is probably the first thing that we need to make sure that we treat in such a way that the weight of that crucible, when we first measure it, is representing what is the what's the real weight of the crucible. What I mean by that is, this crucible has been lying around, we don't know where it's been, we don't know what it has. It could have some organic matter in there. When we ignite when we put this crucible heating it, it will burn the organic matter and cause negative deviation from the real result. In other words, it will make the result go erroneous. Second thing that we will need is a pair of crucible tongs. This crucible tongs is not only to handle the crucible, but it's also part of your safety. Please make sure you always handle hot crucible with a pair of tongs. The next we will require is a steel wool. The steel wool, again, it's used to make sure that any oxidation material or matter on the next element that we're going to use for the analysis is magnesium. Steel wool is used to make sure that the oxidized magnesium is actually washed away or scraped away. I personally, from my experience, prefer using LPG gas for the ignition of the magnesium in the crucible. It just makes it much easier to do. Using methane, which is a cooler flame than LPG, it takes much longer, and you probably have to somehow start the ignition in other ways. So that's the reason you see the bottle here. And the other thing that you will be using is also a pipe clay triangle with a LPG with a tile here. Of course, we started saying that this method is based on gravimetry. Gravimetry is weight, and therefore we want to do accurate measurements. We will require accurate measurement of weight. In order to do that, we use analytical balance. The analytical balance in our laboratory goes to 3 decimals. The first job is to treat our crucible and its lid, making sure any organic matter that it may contain has actually been burnt off. So that's our starting point. Alright. I'd like to also mention to you that crucible is at the moment cold, especially if you're doing this in winter. Putting it immediately on a very hot flame can cause the crucible to crack. So I will suggest that you actually use the tongs and make sure you actually hold it somewhere very strong so you can it's not flimsy, and then gently run it over the flame to make sure that the crucible warms up slowly before you lower it to burn it for approximately 2 minutes to ensure all the organic matter is actually burnt off. And we will do the same thing with the lid. Okay, now our crucible has been heated and treated in the way that we like to make sure all organic matter is burnt, and it's lid. While this is cooling, this is our chance to start preparing the next item in our experiment. The next item is actually magnesium ribbon. That's what we're going to use in our experiment. Typically, I will say use approximately 20 centimeters, 15 to 20 centimeters of magnesium ribbon. And if you just bend it down and then lift it up, it just breaks clean. I'll just bring this to you. You can see the magnesium ribbon surface is not shiny, silvery surface. It actually has some black blemishes, and those black blemishes are corrosion products, and we use steel wool to clean those corrosion products that's been reacting with the magnesium that's been sitting in the store. Okay, here we are using the steel wool. We're making sure all the black stuff comes out. This is magnesium after it's been cleaned up using the iron wool, steel wool. I don't know if you can actually see it. It's still got black blemishes on there. Can you see it? It'll be impossible to get rid of those unless you keep rubbing it over and over again. Okay, the next thing to do is I have to find a way of putting this strip into a crucible. One way that is usually practiced in everywhere I have seen was to use a pencil of some description and to wrap the ribbon around the pencil just softly, so it actually forms something like a spring. So we'd like to see a little bit of air can actually still travel around the spring, because after all we want the combustion completed. See that? Okay. Now we've got crucibles that has been pre-treated and a lid that's been pre-treated, and now we've got a cleaned up magnesium strip. We're ready to start our experiment. The very first thing we have to do is establish what is the weight of the crucible, empty crucible, plus its lid is. So we'll use the analytical balance for that. That's been tailed to read 0. By the way, at this stage, the crucible must be cold. In other words, at room temperature before you start weighing. This is an important point. Make sure that you are consistent throughout the whole of the experiment. So here we are, our crucible plus its lid. That's our weight 1 is equal to 82.249 grams. Into the crucible, I'll add the magnesium strip. If you notice, I'm not handling anything by hand anymore. I'm using the tongs. Although they're cold, I'm using the tongs. That's largely because I don't want to leave any contamination from my hands onto the analytical equipment. Weight 2 is crucible plus lid plus Mg, magnesium, 82.522. So my data is ready. Now I can start the reaction. Again, if you notice that I don't put my crucible straight onto the triangle, I'll have to start up the fire first using safety flame. Please make sure you understand that every time you light up a Bunsen burner, you use safety flame. Okay. So I'm doing exactly what I did first time when I was pre-treating the crucible. I'm allowing the crucible to warm up before I put it onto the triangle. Okay. That's better. And keep watching it so that as soon as you see a sign of sparkle, you close it. That's losing.
So that's how the product looks like.
Yes.
Alright, thank you very much, Mr. Ganj. And now that you've got all the experiment out of the way, I hope you can appreciate that we have now a whole bit of sort of data that we can use for analysis. So starting from the very top up here, I hope you can see that the weight of magnesium really is the differences between the magnesium inside the crucible, subtracted that with the weight of the crucible in the lid, and we got 0.273 grams up here. Now before going any further, let's make sure that we're crystal clear about our objectives. The whole objective of this particular experiment is to identify the ratio, or I should say the empirical formula of magnesium oxide. So it's a ratio between how much oxygen and magnesium are inside this particular compound. So in order to do that, we need to find out the number of moles of each chemical inside this compound. Now, from this mass up there, I hope you can appreciate that we can actually determine the number of moles by dividing that with magnesium's molecular weight, and that gives us 1.12 times 10 to the minus 2 moles. Now, next, we can identify the number of moles of oxygen in the compound. So therefore, when you think about this for one moment up here, if you're looking at this particular figure up here, the weight of magnesium oxide plus the lid and such will give you 82.695. So therefore, if you want to find out how much magnesium oxide was in the crucible at the end of the reaction, all you have to do is subtract the mass of the crucible and its lid, which will give you a figure of about 0.446. Now this is magnesium oxide, not the oxygen in the magnesium oxide. So to be more exact, alright, the weight of oxygen up there will be the differences, how much the magnesium has gained its weight throughout the reaction. So this is the final mass, alright, of the magnesium oxide, and this 0.273 up there comes from the weight of the magnesium that we actually determined early on in the calculation. So the differences, hopefully, must be coming out from the oxygen attaching itself on the magnesium oxide compound. And that will give us 0.173 grams in this case. Now, remember, we want to find a ratio, isn't it? So that was crucial for us to actually change this mass back to number of mole, and thereby we divide that by the molecular weight of oxygen, which will return you with a result of 1.08 times 10 to the minus 2. Alright, so if you actually look at these two figures up there, they're roughly close to 1 to 1, but I just want to make sure they're absolutely certain. So I just go through the mathematics up there. So strictly speaking, mathematically speaking, that's 1.12 to 1.08. Yeah, I don't like that. I want to actually see 1 to integer ratio and such. So therefore I divide both of them by 1.12, and that gives me 1 to 0.96. Now remember, there are losses in this experiment. Early on, when we actually lit the lid, you would see a little bit of white smoke. The smoke itself will carry fine powder of magnesium oxide, so you expected to lose some of it from your experiment due to the very fact that it was evaporating with the smoke, and on top of that, you might actually lose some of it during transfer and such. But I would say around about 4% differences. That's quite good as a scientific experiment conducted in a high school laboratory. Thank you very much for watching. Hope you learned something today, and thanks again, Mr. Ganj.
Thank you.
Study magnesium.